Hey guys, these notes are for parabolic parts and graphing standard form. It's the first section of notes for Unit 7, so welcome. Essential question is, what are the key characteristics of quadratic functions and how can I find the vertex by hand? We have some vocab for this unit. We have a ton actually that takes up the whole first page and about a quarter of the next page, but I'm going to be using these words for the entire unit, so we do need to know all of these words. So let's begin. Alright, so a quadratic function is a nonlinear. And nonlinear, what does that mean? It means it's not a line. Second degree polynomial. Okay. So we did talk about like the degrees of polynomials back in Unit 1. So if something's a 7th degree polynomial, the highest exponent in that entire expression would be a 7. A 3rd degree polynomial would be the highest degree is 3. So if it's a 2nd degree polynomial, then the highest degree we see will be a 2, which is the highest exponent. So standard form of a quadratic function, we've talked about this before. That's ax squared plus bx plus c. But we're talking about functions now. We're not just talking about the standard form of a quadratic, it's a function. And functions have inputs, and then you receive an output, which means we have an equation. So y equals, or f of x equals, right? They're the same thing. F of x is just function notation, but it's the same thing as y. You're still getting an output. Okay, so those are the same. All right, a parabola is the u shape of a quadratic function. Okay. Also, if you're not taking notes, you need to print out the notes or be taking them on your iPad. Make sure you're taking notes during this. It's mucho important. Is mucho the right word to use? I have no idea. Okay, anyways. So there's two types of parabolas you'll see. Oh, let's talk about the first one. If a is positive, then the parabola opens up. Basically means it's facing up. Okay, it's not saying like it's going to close if it's negative, but it's going to open up, as in it's going to face up. Okay, so your parabola will look like that. So if a is positive, it will open up. And when we're talking about a, we're talking about the a in here, a in your standard form. Okay, if a is positive, then it will open up. And you can think about that as a positive smiley face. It will open up. Okay? Now, let's use yellow. If a is negative, the parabola opens down. Okay? So it will open down. It doesn't close down, okay? Parabolas still get wider and wider, but it's like a sad face. Negative, it's going to phase down, okay? So that's an easy way to remember. If that's the only way you remember, whatever works for you. Okay. Moving on, the vertex. That is our highest or lowest point. Oh, I'm sorry. All my handwriting is bothering me right now. Highest or lowest point. Okay. I did leave some space because I am going to draw two parabolas. You're either going to have a parabola that... Geez, I cannot draw a parabola right now. Okay, it's either going to face up or it's going to face down. Okay. So you'll have either or. Now, if you have a parabola that faces up, are you going to have a lowest point or a highest point? Here you're going to have a lowest point, so that's going to be your minimum. That's the minimum point, the lowest one. If your parabola faces down, okay, if it faces down, you have a maximum point. All right. Next is axis of symmetry. I'm going to draw a picture first, and then we can talk about the definition of it. Okay, So let's just draw a parabola. Let's draw a baby blue one. Okay, so we have this blue parabola here. Now, if I took a heart and I asked you to cut it symmetrically, what would you do? Well, you would take it and you'd cut it in half, right? Well, it doesn't matter how you cut it in half. Can you cut that's a horrible heart. Could you cut a heart in half like this? Would that be symmetric? No. Cutting a heart symmetrically means you cut it in halves, but both sides are like mirror reflections of each other. Same thing with the parabola. You want to cut it in half so that it's a mirror image. So you would cut it down right down the middle, and it just happens to go through your vertex, okay? Because your vertex is like that middle point of the reflection. So the axis of symmetry formula is the vertical line that goes through the vertex. That's important. And cuts the parabola into equal parts. Oh, handwriting is garbage right now. Okay. There's also more room on here, so I need to write 2 more things. The first thing, my ugly cloud. Okay. It is always written as, okay, that line is a vertical line. So what axis does it go through? It goes through the x-axis. So it's going to start with an x equals, and it's going to be some number. So we learned this in Unit 3. Vertical lines have the equation x equals a number, remember? And then horizontal where y equals a number. But these are always written as x equals a number. The last thing about axis of symmetry, over here, the axis of symmetry formula. Okay? Oh, shoot. That's not what I wanted to do. Axis of symmetry formula. Okay, so again, the axis of symmetry is always written how? X equals. Okay, and the formula is negative b over 2a. Okay, so you're basically using the b and the a from your standard form, from the ax squared plus bx plus c. And so we'll have more practice using that formula on the very last page of the notes. All right, moving on. X-intercepts, roots, zeros, and solutions. Okay, so obviously, hopefully we know what an x-intercept. We've been learning that since middle school. But on a STAR test, it might say, what are the solutions? What are the zeros? What are the roots? It might not say x-intercepts. So you do need to recognize that all 4 of these things are the same thing. So if it does ask you for one of those, it's asking for an x-intercept. So an x-intercept is where the function intercepts the x-axis, but I'm going to say crosses the x-axis. Or it meets the x-axis, okay? And let's talk about different types. So let's draw 3 graphs here. And I ask you, okay, now you don't have to draw this on your paper. I'm just going to kind of talk about this with you. I'll tell you when you can start writing again. Okay, so the first thing is, let's draw a parabola like this. How many x-intercepts does this guy have? He has 2. He's crossing here, and he's crossing here. Okay, so this guy has 2. Okay, this guy, let's draw another one. How many does this guy have? Well, he has 1. Okay, now I'm going to ask you, is it possible for me to have 3 x-intercepts? No. It's not possible to have 3. So remember, when we had a line, like a straight line through our graphs, it only crossed the x-axis once. The highest exponent was a 1. For a quadratic, the highest exponent is a 2, so the most amount of solutions, or the most amount of x-intercepts, would be 2. Now let me ask you, is it possible for me to have 0 x-intercepts? Yeah. I could have a parabola that's all the way up there, and it's going up and up and up, but it's never going to touch the x-axis. Or I could have one that's facing down like this. So I could have 0, okay? So you can go ahead and write this part here. You can have 0, 1, or 2 x-intercepts. So that's possible. If we're just talking about one quadratic, it's possible to have 0, 1, or 2. Okay? Let's move on to y-intercepts. That's going to be where the function crosses the y-axis. Okay. And then our last two vocabulary words where we talk about domain and range. All right, so I know it's not our favorite thing to do, but it is something that we do need to identify. And later on in the notes, I'll show you just a quick way to remember what to do each time so you don't have to think about it too much. Okay, so domain is all of our possible x values. Remember, domain has to do with x values, so it's all of our possible x values. And range would be all of our possible y values. Okay? Now, the first thing we're going to do in our notes is graph the parent function. So we just finished all the vocab, which is kind of long, but it's necessary. So we're going to graph the parent function. Now, the linear parent function would be y equals x. So quadratic parent function would be y equals x squared. Okay? Now, if you don't have a calculator, a graphing calculator right now, it is going to be kind of hard to obviously fill out this stuff. But it is important that you do come in and try to figure it out with a calculator because you are allowed to use one. And this explains where I get these numbers. So it's going to be kind of difficult for you to understand that part. So if you can come into the room before or after school, I can explain that. So I'm going to graph the quadratic parent function. So that means you need to get your graphing calculator out and go to y equals, okay? And you're going to type x squared. Now the X button is the green button that is, it's next to the green button, the green alpha button. So it says like X, T, O, and N on it. So that's your X button, and then you just hit square. Okay? Now, I need to see the table. I need to fill out this table in order to graph. So I am going to hit second graph, and that will bring me up a table. Okay? Now, I don't want you to write this yet if you're watching the video. I just want you to kind of watch. Okay? Once you hit second graph, you should see an X and a Y table. Okay? And I'm just going to pick some. I'm going to start at -4. Why -4? Just because. Now, I'm not filling out my table yet, so you shouldn't be writing. I'm just kind of talking to you about what you might see on yours. Okay. So this is possibly what you might see on your calculator. Actually, it will be what you see on your calculator. If you don't see this, then it's wrong. Now, again, you can scroll up and down that list. So I could go all the way up to like x to be -25 if I wanted to. But realistically, am I going to make you graph a point that's like 25, 50 on your graph? No, because that's way too big and it's not going to fit. All right, so here's how you determine how you fill out this table, okay? We're basically looking for, if you look at a parabola, right, it looks like this. And what you notice is, remember that axis of symmetry means that this side and this side are the exact same, okay? So they should have the same exact y values on both sides. So here, your x values are always going to go from decreasing to increasing. It's always going to be like, it's going to go from 0 to 100 or whatever. It's always going to go into increasing order on that side because it's the independent variable, so it's not going to change. You will always see those numbers on the left side. But on the right side, you're going to have different numbers because it's the dependent variable. Now, I want to ask you, do I have any other 4s on this y side? Yeah, I have one right here. Oh, whoops. These are my phone. These are matching, okay? I call them twins, just to remember. So we have a set of twins. And what you're trying to do is you're trying to get closer and closer to the one that doesn't have a twin. So then the next number I'm going to ask you is, for 1, do I have a twin? Yeah, this one, okay? Does 0 have a twin? No. That is the number that goes into the middle of your table. You'll have 5 spots, and 0, 0 will be in the middle, okay? So you're going to plug in 0, 0 for the very middle of your table, and then you're like, well, what do I do for the other 4 points? Okay, so the other 4 points, so this is your vertex, so that goes in the middle, okay? Your vertex is the point that doesn't have a twin because it's the lowest or highest point. The other 2 points are going to go from the ones that are right above it, the 2 points above it and the 2 points below it. So you'll just copy that down. 1, 1, 2, 4. Obviously, this is really hard to explain if you don't have a calculator, so unfortunately, you just kind of have to copy that down if you don't understand it. All right, so what do I do next? I graph them. So I'm going to graph the point 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Oh, that's a 5, actually. Okay, and then you kind of just connect them and make a quadratic, little parabola shape, okay? Once you finish graphing, you can actually identify these. So your vertex, what is your vertex? Remember, it's the highest or it's the lowest point. So here it would be 0, 0, and it's a point, so I do need an ordered pair. And if you notice, that's actually the point that we have in the middle here. Your vertex will always be the middle of your table because we want to be able to see a quadratic, and I don't want you graphing like part of a quadratic on your graph like that. I want to be able to see that U shape, so that's why we want the vertex in the middle, and then we want the 2 points next to it on the left side and 2 points next to it on the right side. Okay? Now, min or max. Is this one going to be a minimum or a maximum? This one's going to be a minimum because there's the lowest point here. Okay, we talked about min and max on the first page. Axis of symmetry, remember that's always written as x equals, okay? And we talked about how the axis of symmetry goes through our vertex, correct? It's a vertical line that goes through our vertex. Well, our vertex is 0, 0. What's the x value of the vertex? 0. So these numbers are always going to be the same, okay? Y-intercept, y-intercept would be here 0, 0. The x-intercept, again, is still 0, 0. Crosses the x-axis and the y-axis at the same point. Now your domain, let's think about. If I go as far as I can to the left of my x-axis, does my graph keep going? Does it ever stop? Keeps going, right? It's never going to stop. If I go to the right as far as I can, it will keep going no matter what. So for my domain, it's going to be all real numbers because it's never going to stop. Okay, remember that we write that R, that double bracket R. Okay, and then our range is our y values. Now, my parabola, the lowest y value I have is what? A 0, okay? It doesn't go beyond this point, right? There's nothing down here. So, our range is never going to be all real numbers for that. Okay, but we know our ranges are y values, okay? Now, are all of our y values going to be bigger than 0 or less than 0? They're all bigger than, so they're going to be either greater than or equal to 0. And you're like, I don't like this. And I'm like, it's okay. We're going to use these two things down here to remember our domain and range, okay? Now, domain, for quadratics, the domain is always all real numbers. Okay, it's always all real numbers. You can plug in literally any single x value that you want in the whole world, and it will still give you an output. So, all real numbers. Okay? For the range, you're going to look at the y value of the vertex. Okay? Why? Because your vertex is your lowest or highest point. It will tell you either the minimum point or the highest point that your whole entire y values can be. So you're always going to look at the y value. And let's look at the parabola we just did here. Did it open up or did it open down? It opened up. So let's say for the one that opens up, what did we use for our range? Did we use y is greater than or equal to, or y is less than or equal to? We use y is greater than. So you're always going to use y is greater than a number. Okay? If it opens up, you have greater than, right? Think about how all your y values are up. They're all greater than. Okay? The bigger y values are going up. So that means if it opens down, then it's going to be y is less than or equal to a number, okay? And that number is always the y value of your vertex. You can literally use all of this information by itself. You don't even need to graph it to get that information, really, okay? So once you know the vertex, then you can know all the other information. All right, let's move on to the second example. All right, so we need to graph y equals x squared plus 6x plus 2. Now you're going to do that in your calculator. You're going to hit the y equals button, okay? You're going to hit the y equals button, and then you're going to type in x squared plus 6x plus 2, okay? Make sure you type it in exactly the way you see it. Now, while you're typing it in, I want to ask you, what is our a value here? What is our a value? Okay, our a value here is 1. So is 1 positive? Yeah, so should this parabola open up or down? Okay, it should open up because a is positive. So once we graph that, we'll know for sure. We should be able to graph for sure, because we do want to make sure that we graph it correctly and that it matches our equation. Okay, so now I have a table. Obviously, if you're at home and you don't have a calculator, it will be hard for you. Okay, so this is what you might see on your table right now. Okay, let's start at -6, -5, -4, -3, -2, -1. Okay. Whoops. Okay. All right, so let's look. Okay, again, your twins are going to surround. The closer you get to your twins, the closer your twins are getting to each other, that's the closer you're getting to your vertex. So your vertex is always going to be in the very, very middle of all the twins. So again, look, these are always going to go from decreasing to increasing order, so I don't really care about the x value side. I'm going to look at this 2, and I'm going to search, do I have a twin? Now, on your calculator, you might have to go up a few, but you should be able to find a twin for it. So I do have a twin for 2 here. Okay. -3, do I have a twin? Yeah. -6, I have one. You see how we're getting closer and closer to each other? Where I don't have a twin is right here. -3, -7. Okay, -7 doesn't have a twin. That's the number that goes in the middle of your table. It's the one that is not a twin, the one that's single by himself. He goes in the middle, okay? And then you're like, wait, I forgot what to put on the outside, what to put on the other 2 points, okay? That's going to be whatever 2 points are above it and whatever 2 points are below it, okay? So you're going to put -5, -3, -4, -6, -2, -6, -1, -3, okay? Whatever 2 points are sandwiching both sides. Okay. So let's go ahead and graph this. We have -3, -7. I know, I'm sorry that my graph is not big enough. That's my bad. It's just because I was, what's it called? I didn't cut a big enough piece of paper. Okay. Those are my 5 points, okay? Remember for lines, I asked you to graph at least 3 points. For quadratics, I need you to graph at least 5 because I do want to see that U shape. I don't want to see like a quadratic function where you graph like 2 points or 3 points like this and it's like half of one. I don't want to just graph 2 and just see this, okay? I would love to see a U on your graph, so I do want you to graph at least 5 points. Okay? Now the vertex, remember that's the lowest point of your graph or the highest point of your graph. But you also know that from the middle of your table, it's going to be their middle point here. So that's going to be -3, -7. And remember, it's an ordered pair, it's a point. Now your min or max, it's going to be a min this time, again, actually, because there's a lowest point. Remember, it's opening up. And we're correct, because over here, A was greater than, A was positive, so it's going to open up. Axis of symmetry is always written as x equals. And remember, it goes through the vertex, so what's the x value of your vertex? -3. I'll highlight that for you just in case you forget. Okay? Our y-intercept. Now I want you to scroll through your calculator. Now, how are y-intercepts always written? They're always written 0, number. So looking through your table on your graphing calculator, look for your y-intercept. It's 0, 2. Okay? Even on our graph here, yeah, we have it right down here, 0, 2. That's our y-intercept. Our domain is always all real numbers, okay? And our range, so here, it opens up. So are you going to have y is greater than or equal to, or y is less than or equal to? You're going to have y is greater than or equal to, and it is always whatever the y value for the vertex is, so it'll be -7. See, not too bad. Range and domain should not be too bad. Domain is always all real numbers for quadratics. That was like a freebie for you, basically. Down here, I have a thing about y-intercept. So here's a trick for y-intercept, so you don't have to look at your table every time. Okay? Our y-intercept here is what? 0, 2. Remember, you must write it as an ordered pair. Do you notice that do you see any 2's in your equation? Yeah, right here. So Your y-intercept is always, or actually I'm just going to say it's the c value of the equation in standard form. So whatever that c value is, that's your y-intercept, okay? All right, last graph. We need to graph y equals negative x squared minus 8x minus 8. Now, if you feel really good about this and you have your calculator, you can go ahead and graph it. I do want to make sure that you are very careful. That first sign is always going to be a negative sign. So if you have something in the front, that's a negative sign. Okay? You don't want to put a minus sign in the front. You will get an error, and I won't be able to help you on a test, and no one's going to be able to help you on the star. So make sure you plug in a negative for that. This is a minus sign, and this is a minus sign. Okay? So make sure you plug in those symbols. You don't want to put in a minus sign for all. You'll get an error. You don't want to put a negative sign for all because then you get something else. You get something huge. Your table will go crazy. Okay? So negative x squared minus 8x minus 8. Second graph. Okay? Now you're just going to scroll through your table and look for some twins. Okay? So if you don't have a calculator, this is what I'm seeing for some of it. Negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1. Again, it's always going to go from in increasing order. Increasing, I don't know why I said that so funny. Okay, anyways, moving on. Now, again, your numbers are not going to ever be too big for you to graph. So if you're up into the y values where it's 35, you went too far. Okay, I'm never going to make you graph something that huge because it's just, maybe for a real application problem, but for just graphing in general and looking for the vertex and stuff, it's never going to be that huge. All right, negative 1, I have a twin. 4 has a twin. 7 has a twin. 8, however, does not. Okay? So, over here, I have negative 4, 8 in the very middle of my table. Okay, and I know my graph's not big enough. I'm sorry. And then your 2 points around it are going to be the ones that are going to be the other 2 points. Sorry, I lost my train of thought. Okay. So the vertex here, actually, I can get all this information right now. So let's go ahead and do that. The vertex here is going to be negative 4, 8. Okay. Now, is this going to be a min or max? So let's look at our equation here. Was A negative or was A positive? A was negative 1, right? So it's negative, which means it should open down. It should look like this, which means I'll have a maximum. And once we graph that, you'll see that. So you'll see the max on there. Axis of symmetry always starts as x equals, and it's whatever our x value for the vertex is, which is negative 4. Our y-intercept is always the c value of our equation, which is negative 8. So your y-intercept will be 0, negative 8. Domain is always all real numbers. And remember, your range is always going to be either y is greater than or equal to, or y is less than or equal to. Well, our quadratic, we know, faces down. So it opens down, which means it's going to be y is less than or equal to. Remember, down means less than, up means greater than. Okay? And it's always the y value of your vertex. It's always going to be that. So let's use blue. Y value of your vertex. This one's going to be the x value of your vertex. Okay? So you're always going to use those. And now let's actually graph this. So I have negative 6, 4. I'm sorry that this one actually goes off as well. That's my bad. I need to be better at giving you guys enough graph paper. The good news is that you have graph paper, right? I could have just made you draw a graph by hand. But, I was nice enough to cut that out. Unfortunately, it was not too big enough. Okay, so it does face down. It's all the way up there. Okay? So that's how we graph quadratic functions and find all of those key features. And we're going to move on to the next section of the notes, which is how to find the vertex by hand from standard form using the axis of symmetry formula. Okay? Now from the very, very, very front page, the axis of symmetry formula. Remember, axis of symmetry always starts how? X equals. Okay? It's going to be x equals negative b over 2a. Okay? For all of these problems, you need to find the standard, you need to find the vertex, and you need to find the axis of symmetry. Now, the axis of symmetry will help us find the vertex, so we're always going to find that first. Okay? So, the first thing I'm going to do is I'm going to identify A, B, and C. Okay? What is my A in this equation? 2. My B is -8, and my C is 6. Okay? So over here, I'm going to go ahead and start solving. I have x equals -b over 2a. Now, I know my b value is -8. I want you to be careful because there's already a negative sign with this. So it'll be like a double negative. So you'll have x equals negative, your b value is going to be -8, divided by 2 times, anytime you plug in a number, I want you to plug it in parentheses. It will help you and you will not screw up as much. Your a value is 2 here. Okay, again, I'm just using my a, b, and c. Now, if you can do the top part, the double negative, if you want to just put +8, that's okay. I just wanted to do it in 2 steps. So, -1 times -8 is +8, right? You have a negative here and a negative here, so they cancel each other out. And that's going to be divided by 4, because 2 times 2 is 4, so that simplifies to 2. So, our x equals 2. Now, what did we just find? What was that formula for? The axis of symmetry. So we know that the axis of symmetry is going to be x equals 2. Now, am I done? I am not done. I want to go back and I want to show you something. Where did we get the axis of symmetry for this one? The x equals -4. Where did that number come from? It came from this number, right? It came from our vertex, the x value. So that means that the x values for the axis of symmetry and vertex are always going to be the same. Okay? So that means for my vertex here, let me do it in green. My vertex will always have the 2 as an x, or always have the same x value. So I already know that there's 2, I already know the x value. I don't know the y value, however, and I need to find that. So I'm going to go ahead and box that like I'm ready to answer, but I need to find the y value still. Okay? So I'm going to go over here. I now know that x equals 2. Now I can basically use substitution. I can substitute the 2 in for x. So I'm going to plug in a 2 here. Anywhere I see an x, I'm going to plug in a 2. Okay? So I have 2 times 2 squared. Anytime you plug in a number, you are going to use parentheses, okay? You need to use parentheses or you will mess up, especially if the number that you plug in is a negative. Okay, so plug in a 2. Now, if you're in on level, you can actually go ahead and type this one up into your calculator, and if you type it exactly the way you see it, it will give you a number. It will solve it for you, or it will simplify it for you exactly. However, if you are in pre-AP, you need to do it by hand, so I'm going to do it by hand right now in the notes. So y equals, I know that that's 2 squared is 4. -8 times 2 is -16 plus 6. Y equals 8 minus 16 plus 6. That's going to be y equals -8 plus 6. So what does y equal? Y equals -2. Okay, so that simplifies to -2. So is that our answer? No. Y equals -2. So that's the number that's going to go over here, -2. Okay? We're basically finishing out our vertex. All right, number 2. Okay, we have A, B, and C. We need to identify those first. You always identify those first. Our A here is what? Remember, A is always attached to x squared. In this case, it's -1. Okay? Our B is 6. And our C, we don't have one. Remember, C is the one that's just, it's a constant. It's the number by itself. It's not attached to any variables. Since we don't have one here, if there's nothing, remember nothing as a number is 0. So C is 0 in this case. Now I'm going to use my axis of symmetry formula, -b over 2a. Okay, so it's going to be x equals -6 over 2 times -1. Okay, I'm plugging in my b and I'm plugging in my a. So that's going to be -6 over -2, which is +3. So x equals 3. That means my axis of symmetry is x equals 3. Okay, which means that my vertex has the x value of 3, and I need to find the y value. Okay? Don't know the y value yet. So I'm going to solve for the y value. Since I know that x equals 3, I'm going to plug in a 3 for the x's. Now remember, anything that you plug in, you put in parentheses, which means that this negative sign out here is going to go out by itself, and you'll have a 3 squared. Okay? That's plus 6 times 3. Okay? Now, I do want to stress the importance for you and those in pre-AP, since you're not typing it in the calculator exactly. Again, if you're on level, go ahead and type it in exactly how you see it, okay? Exactly how you see this. Now, when I'm talking about how you type it in, I'm talking about in the main screen where you do all your calculations. Don't type it in for y equals, okay? You could, but it's just kind of a longer process. Just go ahead and type it in. You would hit second mode, and it'll quit to the home screen, and you can type it there. I do want to stress the importance that negative 3 squared is not the same thing as negative times 3 squared, okay? These are not the same. They're not exactly the same, okay? One has a negative on the outside, and one has a negative on the inside, which means that this negative is going to stay out there, and then I'll do 3 squared, which is 9, and so that'll give me negative 9, okay? So that negative will stay out there. And then I have plus 18, so I end up getting y equals 9. So I have 9 here for my y value, okay? Last one, this is one you need to be very careful on, okay? Your A, B, and C are always going to be whatever they're normally attached to. Now, don't let it trick you. What's my A value here? My A value here is 1, right? What is A always attached to? X squared. Remember, A, B, and C are numbers, so if I ask you what B is, I don't want to see 3x, okay? You shouldn't have any variables when you're solving for something after you're done. So, A is going to be 1 here because it's always attached to x squared. Our B in this case, we don't have 1. There's nothing where it's attached to just an x, so our B is going to be 0, and our C is 4, okay? So let's use our formula, x equals negative b over 2a. X is going to be negative 0 over, I forgot to put the a, 2 times 1. No, it's not possible to have negative 0, it's just 0. So that's 0 over 2, and that equals 0, okay? That means that I have x equals 0. Axis of symmetry, x equals 0. Okay? Moving on, let's do the vertex. We know that our x value is already going to be 0, and we need to solve for our y value. Okay? Plug in a 0 anywhere you see an x. So 0 there. So I have y equals 4 plus 0 squared. So that's just going to be y equals 4, because it's 0 squared, it's just 0. So I know that my y value is going to be 4. So 0, 4 is my vertex, okay? So in the case where you don't have a graphing calculator, you can find the vertex and the axis of symmetry by hand. If you are in pre-AP, you do need to know this by hand because you will not have a calculator for this section of the test. But if you are in on-level, you will have your calculator for the whole thing, so you can just type that in. If you have any questions, please feel free to come into tutorials. But that is it for our first section of notes. I know it was super long, but it was all like basic information